Okay, let's dive right into this explainer. Following the structure outlined in our source document, ENGV, we're going to look at a mystery that spans centuries, and it all starts with a very specific, almost magical date on the calendar. Today, we're going to see how one single day connects some of the absolutely most groundbreaking ideas in human history.
And that date is July 24th. It's honestly one of the greatest dates in math history. On this exact day, across completely different centuries and countries, brilliant minds were born who radically changed the world we're living in right now. So let's meet them one by one.
Section 1. Patterns inside the chaos. Let's kick off our detective story with our first real-world wonder.
So, have you ever actually stopped to wonder how your screen takes raw data and renders millions of complex shapes and colors to build, a perfect digital world? Whether you're playing a visually stunning video game or watching the latest animated movie, there's this hidden architecture holding all those pixels together.
Well, the answer actually goes all the way back to July 24th, 1923, and a truly brilliant person named Mary Hamill. She was born in London and became this incredibly talented mathematician who just had a special flair for seeing order where everyone else just saw noise.
She was able to find patterns in the chaos by studying group theory and finite geometry. Now, to put it simply, group theory is the mathematical study of symmetry. Imagine taking a super complex 3D shape and rotating it. Hamill essentially figured out the hidden rules that organize those multi-dimensional structures. And by doing that, she helped lay the mathematical foundation that literally powers the 3D digital graphics and complex data systems we use every single day.
Her work poses this fascinating question. What if the patterns hidden in abstract math are the very shapes that build our digital universe? It brilliantly illustrates our first big takeaway here. The invisible, abstract patterns of math are the exact building blocks of our modern digital reality. Every structure you see on a screen is secretly made out of these mathematical rules.
All right, still on July 24th, but we're going to jump back in time just a few years to 1917 to meet someone who changed how we actually learn these kinds of complex ideas.
Section 2. Joy of problem solving. Let's move right into our next mystery, which happens to take place inside your own classroom.
We have all faced a difficult challenge, right? A moment where a math problem just looks completely impossible. But how do we unlock the confidence to know that we can conquer it ourselves without a teacher just handing us the answer?
The secret to unlocking that exact feeling goes back to July 24th, 1917, and a super inspiring teacher named Clarence Francis Stevens. Orphaned at a really young age, he worked incredibly hard to educate himself against all the odds, eventually becoming the 9th African-American to ever earn a PhD in mathematics.
He went on to create what became known as the Morgan-Potsdam miracle. He realized pretty early on that traditional lecturing just wasn't the best way to learn, so instead, he designed a teaching method with almost 0 lectures, focusing heavily on independent problem solving. He really pushed his students to know when they know, meaning they didn't need a teacher to validate the right answer. They could prove it themselves by truly understanding the core logic. He showed that if we just figure out the inner workings of a problem on our own, we become completely unstoppable.
The absolute crucial point here is that learning isn't just about being spoon-fed the answers. Like Stevens showed, it's about finding that pure joy of discovering them yourself. Because once you find that joy, you never want to stop learning.
Okay, same date, but 8 years earlier. We are moving to a completely different country now, for a mystery of absolute life and death. Section 3. Breaking the Unbreakable Code. Let's dive right into our final mystery for today's explainer, and this one deals with ultimate secrecy.
Think about this for a second. When we send a private text on WhatsApp, or send a bank detail, or shoot off a confidential email, we just trust it stays private. But who originally figured out how to scramble and unscramble secret data so effectively that literally no one else can read it?
The bedrock of that technology traces back to July 24th, 1909, and a brilliant Polish cryptologist named Jerzy Rozycki. He was born into a world that was about to be plunged into war, a war where information was honestly just as vital as physical weapons.
During World War II, the German military used a machine called the Enigma to send messages that they fully believed were completely unbreakable. But Rozycki helped crack this code by inventing what he called the clock method. Here's how it worked. First, they'd intercept the encrypted messages. Then, instead of just guessing blindly, he analyzed the statistical properties of the German language, like knowing which specific letters pop up most often.
By looking for these linguistic patterns in the intercepted text, his method instantly cut down millions of impossible lock combinations. And it's that exact same logic that protects our online passwords and secure messages today. I mean, it's just wild to think about. A mathematical breakthrough designed to completely unravel a mystery and save lives during a global war became the very foundation for the cybersecurity we rely on every single day. The invisible shields protecting our messages today truly were forged in the fires of cracking the Enigma.
Section 4. What connects them all? One date, so many incredible stories.
Let's take a look at how this all builds together. Look at this lineup. Every person we met today, Mary Hamill in England, Clarence Steffens in America, and Jerzy Rozycki in Poland, from completely different centuries and countries, all ask the exact same question. What is the pattern hiding inside the chaos? Hamill found it in geometry, Steffens found it in human learning, and Rozycki found it in encrypted language. And because they asked those questions, our world today has advanced computer graphics, deeply empowering learning methods, and a secure internet. It leaves us with one really powerful thought. If 3 people, all born on July 24th, could change the world this much just by looking for patterns in the chaos, what amazing breakthroughs might be happening in the world today? Keep looking for the patterns, everyone. I'll catch you in the next explainer.